Hey folks, Mr. Dell here. We are using, in this case, it's going to be Pythagorean Theorem, I believe, in solving a word problem. But let's start off by building a diagram and interpreting what we're given. So I'm taking this problem from CPM, Course 3, and this is the closure question, but specifically 10-75. So it says, Ella's cat has climbed up onto the roof of her house and cannot get down. The roof of the house is 24 feet above the ground. The fire department has set up a 28-foot ladder to climb to rescue the cat. The base of the ladder is resting on the ground, and the top of the ladder extends 2 feet beyond the edge of the roof. How far away from the base of the house is the base of the ladder? You may want to draw a diagram to help you solve. Okay, so we've got this house, right? So I'm going to draw what we have here. So this is my house, right? The edge of the house right here. And it says that the house is 24 feet. That roof line, right? That roof extension is 24 feet off the ground. Okay, so if I had the house here, right, I could say that this is my house. I don't need to draw it completely, but there's my house. All right, there's my house, and it's 24 feet. So from the edge of the roof to the ground is 24 feet. Okay. And then there's a ladder that's resting along this, and the ladder extends, it says 28 feet, and it's resting on the ground, but there's still, the ladder ends here. There's 2 feet above the fence, it says. It's resting on the ground. So if this is my base of my ground, it's resting on the ground, but 2 feet of it is beyond the edge of the roof. So it's up here. So that way they can climb up onto the roof. So that means that length there is actually, so this is 24, right? I don't want to get our things messed up here. So this part is 24. So from here to here, that would be, if that's 2, but the whole ladder is 28, that means that's 26 feet from there to there. So it asks then, it wants to figure out how far away. So it wants that distance, the distance from the edge of the house, the base of the house to the ladder base. So really, I've got this, I'm going to redraw it so we can see it better here. I've got this triangle, and there it's a right triangle, right? Because you're dealing with the roof and the ground, creating that 90-degree angle, where this is 24, this is 26, and it wants to know what that length is. So this is where Pythagorean theorem comes in, right? We know that if I have a triangle and it's a right triangle, any right triangle, right? Call that A, B, and C. As long as it's a right triangle, if that, then A squared plus B squared. If I have the legs squared, the sum of the square of the legs is equal to the hypotenuse squared, right? A squared plus B squared equals C squared. A squared, the legs squared, the sum of their squares, add and equal the square of the hypotenuse. So I'm going to do that for this one. It would be 24 squared plus x squared is equal to 26 squared. 24 squared. I'll use a calculator for that. I think I, at this point, should have that one memorized. 24 times 24 is 576 plus x squared is equal to 26 squared, which is 676. So 576, 676. If I now solve for x, I'm going to subtract 576 from both sides, and I get x squared is equal to 100. So what do we do to solve for x? Remember, the inverse of squared is square root. So x is going to equal the square root of 100, which actually, that is a perfect square. It actually equals 10. So how far is the base of the house from the ladder? So it's 10 feet. So 10 feet is my final answer, right? That's the length from the base of the house to the base of the ladder. Okay, there we go.